Texas Utilities, a major supplier of electricity. The mining unit operates several lignite mines in the strip mining method, employing drag lines for overburden handling. As the mines progress, the amount of overburden increases in some of them due to dipping coal seams, and the drag line operation comes to the limit of its economical application. It became necessary to deal with the question of how to integrate additional mining equipment for handling the layers of overburden which exceed the normal digging height of the drag line. The Big Brown mine of Texas Utilities Mining Company is the first one to make preparations for a new system which assures delivery of coal to the power plant. To achieve the final goal of feeding electricity into the network to satisfy all levels of demand, the study was carried out long before the actual mining equipment reached their capacity limits. A large variety of solutions had to be looked at, but of course the most efficient one had to be the one selected. The very flexible truck shovel system was under consideration, as well as scrapers and other single-unit machinery. Another possible system, featuring the continuously digging bucket wheel excavator, which would load onto a shiftable belt conveyor line installed all along the pit and end around to serve the last component in the chain, the spreader, located on the dump side of the mine. There was one more proposal, and it turned out to be the final choice. While the material is under preparation in our Zweibrücken plant for manufacturing the machines, let's see what Demag's concept is in this project. A major consideration was to be that all components would be completed in the workshops to ensure a high degree of quality and to arrange for easy assembly later on the erection site. The majority of the different components are designed as lattice girders built from pipes in varying sizes, and the precise preparation of the tube ends is mandatory to allow proper connections in welding zones or joints. This assembly gear holds the first main tube of a girder section and keeps it in position until this tube extension will be welded on, as well as all other members, which are needed to form a so-called boom section. This procedure guarantees that it will have the exact same measurement as the previously made section. In this example, 2,498 millimeters, or approximately 98 inches. In our Benrad plant, meanwhile, the major parts of the main frame of the spreader were fabricated, and the pre-assembly of this huge box girder is under progress. Pieces up to 130 tons or 290,000 pounds move into the outside assembly area. The availability of overhead cranes and the close-by workshop makes it easy and convenient to position the segments to one another. It is the final step before all the drilling can take place, which will give the erection crew the advantage of fast bolt-together work. Four of 6 mounted crawlers receive their last checkout. They are complete in all respects. Only the crawler pads will be shipped separately to avoid transport problems. Ready and carefully prepared for their future task. These crawlers passed the examination of the Quality Control Department and obviously they are needed first on the erection site. So they are shipped first. By the way, this heavy-duty crane is another Demag product. Transportation, a vital part of the overall project. On the one hand, it was Demag's intention to send components as complete as possible, but on the other hand, rules and regulations would not allow land transportation of pieces exceeding certain dimensions. Basically, the design department had taken care of the problem, but still some special permits were needed, as well as experienced heavy-haul trucking companies for safe loading and securing of the oversized or extremely heavy pieces. For the first major shipment, components manufactured in different locations were ready to leave at about the same time and were sent out to the harbor at the Rhine River. Here, a steering arm is sent on its way. A permit for transporting the trawlers you already saw undergoing the final quality control will only be given for light traffic periods, such as late at night. This is an 80-ton or 175,000-pound and 15-meter or 49-foot load per trawler passing the gates of the plant en route to the Mannheim Rhine Harbor. In the morning, we find the trailers already in the unloading phase, and there is something else important to point out right here. To avoid multiple handling of the freight, which may cause damage, the pieces are loaded into the barge of a unique forwarding system. As soon as stowage and securing of all parts is completed, the barge will be closed, absolutely waterproof, and floated downriver to the nearest ocean-going ship terminal. There, the whole barge is transferred onto a vessel which carries several units across the Atlantic. Then they are distributed to their various destinations. This system has another advantage. The goods never are exposed to seawater or aggressive atmospheric condition. Several barges of our shipment have arrived at their dock in the Houston area. In this way, approximately 4,000 tons or 8.8 million pounds of freight related to the new mining equipment have been shipped. This component does not represent much weight, but the dimension of 4 by 4 by 16 meters or 12 by 12 by 52 feet demands the full attention of the trucking company. Escorted by police, a wide load arrives at its final destination, the erection site of the XPS system, about 320 kilometers or 200 miles north of Houston. It is a part of the smallest machine of the new equipment, the compact bucket wheel excavator. Last handling in the transport sequence. All components of the bucket wheel excavator are unloaded close to each other, and erection progresses fast once everything is on site. responsibilities of the overall project manager, whose residence is in Dallas, close to the customer. Smaller parts are bolted to the bucket wheel boom, while the entire discharge boom is being prepared to be lifted and put into its final position. "25 meters, or 82 feet, is the total length of this discharge boom, already equipped with all idlers, drives, and the belt. Only slow motions allow safe positioning and proper attachment of the part to the main frame of the machine. The total erection period for the bucket wheel excavator is approximately 3 months and includes the hookup of all electrical components. Again, we are looking at the main frame of the XPS, now mounted to 3 pairs of crawlers. It finally will carry the support structure for a 205-meter or 676-foot long discharge boom and 2 receiving booms. The support masts will reach up to a height of 54 meters or 177 feet, so everything possible is already installed on the ground. Once pinned down after lifting in place, there will be only minor work in high locations. Support masts had to be ready before any lifting in place would start. This avoids time delays and the use of many temporary supports. All over the erection site, you find pre-assembled components as close to their final position on the machine as possible. Very soon after another little checkout, this mast is mounted close to the rear end of the main frame. It holds part of the receiving boom hoist, discharge boom hoist, and the operator's cab. Masts of this supporting system and an adjustable horizontal rope stay system are, of course, designed to hold the unique component of the machine, the discharge boom reaching across the pit. The wind tunnel tested structure of the boom is of lightweight design, and a maintenance car is installed to eliminate walkways. Servicemen can travel along the entire length and reach any point that may require service or repair. Lights and tools are provided and a carrying capacity for normal spare parts. All electrical equipment delivered by a U.S. manufacturer could be installed inside the mainframe due to its huge dimensions. Adequate controls for safe operation. A lift approaches a walkway at a height of approximately 30 meters or 100 feet and makes it easy for personnel to get there. It is the level of the operator's cabin. He controls everything that makes this machine so special, moving overburden from the bench, across the pit, on top of the dragline spoil. Let's follow the path of the material from the one side to the other. With a capacity of 2,000 bank cubic yards per hour, the wheel digs overburden up to a height of 15 meters or 50 feet and delivers into the receiving chute of one of the 2 receiving booms. The belt speed is 4.5 meters per second, or 885 feet per minute. 7.5 meters per second, or 1,445 feet per minute, is the speed for continuation on the intermediate belt on the main frame and the belt of the discharge boom, designed to carry the load of 2 bucket wheels serving the XPS. As the ground conditions may be very unfavorable, the average ground pressure is 14.5 psi. It doesn't travel much, but when it does, the fully equalized roller system always provides smooth rides. Compact bucket wheel excavators were chosen for this XPS application, but the system is not limited to this configuration. Even if we consider our XPS spreader to be a long machine with its 300 meters or 1,000 foot total length, it provides the shortest way of transportation for the overburden, which want to move as cost efficient as possible. Here, we have one solution. Others may vary a little due to other conditions, but the result will be the same. The overburden goes where you want it to go. It was a big task. We provided the solution and results. It was made possible by Lauchhammer. Lauchhammer, a member of the Mannesmann Demag Group.
Since the discovery of fire, man has searched for fuel. The search has been relatively simple, until now. It has become complicated by world politics and economics, concerns about depletion of the Earth's natural resources, the environment considerations, and worker safety. As a result, we have begun to move away from sole dependence on petroleum products and toward the increased use of coal and uranium. The state of Texas, with some of the world's largest deposits of oil and gas, also has large reserves of these 2 energy sources. Efforts are now underway to develop these reserves. It's an exciting undertaking, one which means new approaches to mining operations and equipment use. Success depends on men of talent and imagination, and machines of great size and power. Before 1970, there was little interest in the lignite and uranium deposits in Texas. However, in the wake of the 1973 oil embargo, 5-fold increases in world oil prices, and natural gas shortages, these deposits suddenly became valuable and viable sources of energy. In order to efficiently mine these raw materials, mining companies must have the imagination, advanced planning, and technical expertise required for projects of this size. They must also have equipment of almost incredible size to handle increasing production requirements for successful operations. Equipment to remove massive amounts of overburden, obtain the mineral deposits, move the material to the location for conversion into energy, and reclaim the land when the mining project is completed. Mining operations supervisors must have the commitment and support of their equipment distributors, the areas of equipment application and operation, preventative maintenance and service, parts availability, and sometimes assistance in engineering and design. Plains Machinery Company has made the commitment to provide that kind of support. With over 50 years' experience in the materials handling equipment industry, Plains is one of the nation's largest heavy equipment distribution organizations in terms of the territory covered and in the number of branch locations. There are 10 full-service branches, each staffed with sales personnel trained in equipment operation and application, complete in-shop repair, as well as field service fleets operated by factory-trained technicians. The multi-million-dollar replacement parts inventory is accessible from any Plains branch through a sophisticated online system which provides up-to-the-minute availability and location information. In addition to the statewide network of branch facilities, Plains offers the resources of well-known manufacturers of heavy equipment. Equipment manufactured by Mannesmann Demag, providing German expertise in technology and mining equipment. International Harvester and their line of materials handling equipment. Wabco and their high-performance rated off-highway haul trucks. Plains is also proud to be the major distributor for products built by Iowa Manufacturing Company, including the Cedar Rapids and LJ line of asphalt and crushing systems, and the fine line of products manufactured by Galleon, a division of Dresser Industries. The Plains commitment to the mining industry is more than machines. It also includes men whose imagination, talent, and expertise are vital to solving today's challenges. Men such as Steve Cole of the Mining Division. Steve works closely with mining customers and equipment manufacturers to provide equipment to get the job done.
The industry has seen little innovation in it in the last 20 years because the industry fell stepchild to the oil industry, and there wasn't sufficient incentive on manufacturers' parts, on the part of manufacturers to invest larger dollars in research to a market that was, equipment market that was just about phased out. So now that it's come back and it is the hottest thing going in the equipment business, my customers are telling me that they'd like to reduce their cost in areas such as reclamation, increasing their coal recovery percentage, parting removal, mining of multi-thin seams, ash handling, benching ahead of dragline. These are areas that they think that they can do more efficiently, reduce their cost, and they think they can achieve this by introducing some new technologies such as hydraulics, things like that. To do this, they need the help of large distributors that can be open-minded to introducing new technology, are willing to take a chance.
And men like Dr. Frank Kay, who leads the engineering team. His experience in designing and manufacturing mining component systems is a talent not found in most distributor organizations.
The success of engineering at Plains Machinery is basically like that of all our other divisions. It is dependent on the quality, integrity, and capabilities of the people in the organization. Our group is dependent on all our other divisions: sales, service, management, and engineering. These groups must work hand in hand. The quality and strength of the engineering department is dependent on the quality of service, the quality of our sales, and the follow-through on all of our work. The strengths of our engineering department are high-quality people, people that are technically sound, experienced, and well-rounded, professionals in the engineering business. Our experience is varied. We have years of experience in the mining industry, in materials handling, in oil field equipment, and heavy construction. The direction of the engineering department is basically toward new products, product development, and support of our sales and service organizations. In the line of new products, engineering has directed at the strengths of the Plains sales department. We are working in the areas of materials handling to build structures, conveyors, and equipment to support our sales organization. The direction of our growth is toward a well-planned, high-quality, well-serviced product.
Mining companies also have the resources provided by Joe Terrell, who has over 30 years' experience in the construction and materials handling industry. Terrell directs the overall operation of the mining and engineering divisions within Plains and is a member of the company's board of directors.
People solve problems, not machines, technology, or money. That's why it's so important for the people involved in energy production, in equipment manufacture, sales, and support to all work together to meet the challenges facing us today. Only through the use of these talents can effective long-term results be achieved.
Texas lignite reserves begin in the northeast section of the state and extend to the Mexican border. Both the Longview and the San Antonio Plains branches are ideally suited to provide equipment and support for the industry. Eddie Eisenhower in Longview has spent over 20 years in the heavy construction equipment industry. He and his staff have worked with local mining companies, providing the needed support in service and parts availability. Doug Walters, branch manager in San Antonio, another career heavy equipment man, assists both lignite and uranium mining companies in this area of the state. These two branches, combined with the other 8 in the Plains system, have the facilities and resources needed to assist any mine operation. At Plains Machinery Company's headquarters in Amarillo, President and Chief Executive Officer Morris Bailey sums up the company's business philosophy.
The problems encountered in the mining industry today are not really new. In many cases, however, new solutions are required. Plains Machinery Company, through the talents and dedication of the people you have just seen and the many Plains people whom you have not seen, is committed to finding new solutions to the problems which man has faced throughout history. Our business philosophy is very simple. We can perform any task that is economically beneficial to our customers and to Plains. The only requirements for this philosophy to work are well-defined objectives, business integrity, and open communications between our customers, our personnel, and our manufacturers. We are proud of our successes in the mining industry and stand ready to assist you in providing the men and the machines required to help solve our nation's energy challenges.